In this video, we take a look at GPU rendering with Arnold for Cinema 4D. Throughout the course, I've been using CPU rendering as it is what my PC is built for. I'm working with an empty scene right now. To choose between CPU and GPU rendering, go to the render settings, and under the system tab, you have this device selection section. And using this render device dropdown, you can choose between CPU or GPU rendering. So let's change it to GPU rendering. And that's all it takes to enable GPU rendering in Arnold for Cinema 4D. You've probably heard about some issues or confusions that people have regarding GPU rendering with Arnold. The main issue people experience is that when rendering with GPU, it takes a few minutes for the render to start, even for simple scenes. And they find it annoying and unacceptable. They try a few times with a few different scenes, they become frustrated, and they just roll back to CPU rendering and lose faith in Arnold's GPU rendering. Now let me tell you why this happens and how I manage it. I'll be trying to be as brief as possible. Arnold uses NVIDIA's OptiX technology to render on GPUs, and OptiX needs the shaders and different configuration to be compiled before starting the render. For example, when you add a simple polygonal object and try to render with GPU for the first time ever, the render will take like 1 minute to start, and it basically compiles that specific configuration, and that compilation of that specific configuration is cached on your disk, so it needs to be done once. Now suppose you reboot your computer, open another empty scene, add another polygonal object, and start rendering with GPU. This time it won't take a minute to start, it will start very quickly. Probably you just have to wait a second or two. Now if you add a spline or curve to your scene, now you have a polygonal object and a spline object. This is a new config. If you start rendering with GPU, it will take a minute or two to compile and cache again. In a new scene, if you add polygonal and spline objects, because that specific configuration is saved, the render will start very quickly. Now, if you remove the polygonal object and only keep the spline as this is a new configuration, it needs to be compiled and you have to wait a minute or two again. So now we have three configuration cached: only polygonal objects and splines, and only splines. Now, if we add atmospheric volumes to any of these configurations, we have to wait a minute or two for three new configurations to be compiled and cached, which gives us 6 configurations. And these have to be compiled and cached only once, and it doesn't matter if you turn off your computer, work on a new scene or whatever, those configurations are already cached, and if you add any of those 6 configurations, the render should start very quickly. There can be tons of different configuration, and as you work on new scenes and work with different configuration of geometries and objects and shaders, they will be cached, and you start to notice over time that the GPU render starts more quickly. That cached data will be saved on your disk until you install a new version of Arnold or update your graphic card driver. Now this can be annoying, but it is done like that at the time being, and hopefully it gets better. To remedy some of that annoyance, Arnold comes with a utility to pre-cache some of those configurations. In the Arnold menu, come down to Utilities, and here you can find this pre-populate GPU cache. You need to run this once after a new installation or after a driver update, so you don't have to do it for every single scene. The documentation on this subject is really poor, and that's what confuses people. It doesn't cache every single possible configuration, but it will cache some and save you some time and headache. So let's run this utility. It will take some time to run. It takes about 4 minutes on this machine. And you can see it goes through some of the configurations, including different shaders and geometries. Now the process is finished, and this cache file is saved on your machine, and you can find it in your user folder, app data, local, NVIDIA, OptiX cache in this Arnold folder. This pre-populate GPU cache utility can save you some headaches along the way, but for some scenes that have a specific config that is not available in that cache file, the first time you GPU render that scene, it will take some time to start, but the next render will start much quicker for that particular scene. Okay, let's move on. Now let's open up some of the previous scenes and try some GPU rendering with Arnold. Let's open up this 0206 diffuse ray depth finished scene. What I want to do is to open up the render settings and under the main tab, come down to the texture sections and disable auto convert textures to TX. TX is the texture format that Arnold really likes. It's a MIP mapped and tiled texture format. So if this option is enabled, Arnold first converts your textures to .tx when you start a new render. To focus only on GPU rendering, let's disable this option for now. We come back to it later on. For now, just disable it. Under the System tab, change the render device from CPU to GPU. If you have multiple GPUs and you want Arnold to choose specific GPUs for your render, you can enable this manual selection, which gives you a list of your available GPUs. And you can enable the graphic cards you want to use. As I only have one card, I will disable the manual selection. And now we are ready to start the render. You see the render does not start immediately, as this is the first time we rendered this particular scene and apparently it has some uncached configurations. Let's see how much it takes. So it took about 30 seconds to start rendering the scene for the first time. Now if I stop the IPR and clear the bitmap and run the IPR again, this time it should start much faster. It took only a few seconds to start. Because when we rendered it for the first time, the scene configuration was cached in the GPU cache file, and these few seconds of delay we still experience is because, simply put, the scene is being moved into the GPU memory. For this scene, it took a few seconds, and it will happen every time you start the render for this scene, and for bigger scenes, it might take more. Let's get out of the camera and move around in the scene a bit. So even though I'm using a moderate GPU, it is pretty interactive. I cannot compare the speed of GPU rendering versus CPU rendering, as I have a pretty beefy CPU and a very moderate GPU. Now let me stop the render and open up another scene. Let's open up these 0311 atmospheric volume finished HQ render 02. Let's change the render device from CPU to GPU. The render resolution is full HD. Let's set the IPR scale to around 40%. Clear the bitmap and run the IPR. For this scene, we have to wait about a minute for the first time. If we didn't run that pre-populate GPU cache utility first, it could have been much longer than 60 seconds, or honestly, it could have been the same, as the pre-populate utility might not have any specific configurations that this particular scene has. It's just the way it is. But now if I stop the IPR, clear the bitmap and start the render again, it takes only a few seconds to start, because all the configurations of the scene are cached, and now anytime we start rendering the scene, it will start fast. Let me close this scene and get back to the previous one. I'm going to clear the IPR and set the scale back to 100% and start the IPR again. Let's wait for the render to be finished. As you can see, it's pretty noisy, and dealing with noise in GPU rendering is quite different, because if you open up the render settings and go to the sampling section, you see what's happening here. Only the camera samples is enabled, and the rest of the sampling controls for different ray types are grayed out. Obviously, you can go ahead and crank up the camera AA samples to get less noisy renders, but at the same time, that will get your renders to be very, very expensive and very, very long. The way to add a bit more adaptivity is going to be through the adaptive sampling. So let's enable it from here. We will discuss adaptive sampling in its own lesson. In this section, I'm just going to give you a brief intro. When you enable this option, your camera samples, which is 5 here, will become your minimum samples. And this AA samples max, which is 20, will become your maximum samples. Now you have defined a range of samples, and Arnold can choose from this range based on the noise amount. So if a part of the render is really noisy and hard to solve, like DOF or motion blur, it will use a higher sample count. And if it is a simple white wall, let's say, it will use a lower sample count. The way you control Arnold's sensitivity to noise is going to be through this adaptive threshold. The lower the value, the more sensitive it will be, and it will use higher sample counts. And the way it works, let's say Arnold looks at 2 neighboring pixel values. If they are the same color or very close in color and value, Arnold decides to use a lower sample count. But if the contrast is more between those two, Arnold will send more and more samples per pixel to be sure to give us a correct solve. And what controls that decision is the threshold. The lower the value, the more sensitive it will become, so it will use higher sample counts for more parts. The render will become cleaner, but it will take longer. For most scenes, when you don't have DOF or motion blur, you can set the camera samples to around 3 or 4. If you had depth of field or motion blur, you will need higher min sample counts, maybe 7 or 8. The max sample count, depending on the scene, can be from something like 16 to even 100. The more complex the render is, the higher the value needs to be here. Usually the most important value here is the threshold, because even if you are using a high max sample count like 100, but if your noise threshold is very high, you are opting for the min samples and vice versa. Something like 0.02, 0.015 or even 0.01 can be used for the final render as the adaptive threshold value. Now let me give you a workflow that you can follow at least. I'm going to draw a small render region for faster results. Let's clear the IPR. I start with a fairly low min and max samples like 3 and 16. Then I start decreasing the threshold as low as 0.01. If the render is clean, then that's okay. And if not, then I start increasing the max samples. Let's set the min camera samples to 3 and max to 16. And adaptive threshold 2.2. To speed up the video, I have the results saved in the picture viewer. Let's take a look at it. Now, as you can see, the render with this particular settings is noisy. Now, to make it cleaner, I can increase my max samples or decrease the noise threshold. Let's decrease the noise threshold to something more reasonable like 0.05. And take a look at the render with the settings. Now the render took almost twice as much, and if we take a look at it and compare it to the previous render, you can see it's cleaner. Now let's set it to around 0.02. Now this time it took 25% longer compared to the previous render, but if I compare, you can see it's obviously much cleaner, especially in the high frequency noises. Let's decrease the threshold to 0.01. And if we take a look at the render, you can see it took almost 10-15% longer. And if we compare it to the previous render, you can see it didn't make much of a difference. And now we can start increasing the max samples. Let's try 32. And if you take a look at the render, you can see it took almost 350% longer. And if you compare it to the previous render, we get a cleaner result and less high frequency noise. Let's increase the max sample count to 50. Now it took twice as long as the previous render and we get a fairly cleaner result and less high frequency noise. I think for this scene something like 16 is enough for the max samples count, and the threshold can be around 0.01, and the rest of the noise can be dealt with using a denoiser. Remember, if you have depth of field or motion blur, you might need to increase your min samples as well. It's harder to get a cleaner result when rendering with GPU because it cleans the render only with camera or anti-aliasing rays or samples. So it's a bit harder to get clean renders compared to CPU rendering. Hopefully it gets better over time. Now let's talk about some of the current limitations with GPU rendering in Arnold. Light linking is not supported, so you cannot use the project tab of your lights to exclude and include geometries from certain lights while GPU rendering. Some AOVs like Cryptomatte and Motion Vector are not supported. Some shaders like Toon, Clip Geo, and Trace Set are not supported. Arnold Denoiser or Noise is not supported. And finally, light groups are not supported. Arnold GPU is pretty good if you have at least 2 powerful graphic cards. If you are strictly working with Arnold as your render engine and you have limited resources, I would recommend getting a monster CPU instead of 2 or more GPUs. For example, right now you can get a Threadripper 3970X with 32 cores and 64 threads and an RTX 2070 Super for the same price of 2 2080 Ti's. And now obviously the pricing will depend on where you live. Now before wrapping up the lesson, let's talk about some of the remaining GPU settings. If you encounter an error while GPU rendering, it's because this fallback is set to error. And when this is set to error, when you are rendering with GPU and you encounter an error, this will stop the render. Now you can change these fallback settings to CPU, and now if an error happens when GPU rendering, the render will go through with CPU rendering instead. Min memory is the minimum free memory for a GPU to have available to be selected when automatically selecting GPUs. So if a GPU has less available memory than the defined value here, it won't be used for GPU rendering. And we have this max texture resolution option that clamps the resolution on MIPMAP textures for GPU rendering. So if you put in 4000 here, no MIPMAP texture can be more than 4000 pixels in resolution. By default, it is set to 0, so there is no limit. We talk about MIP mapping in the texture settings lesson in this section. So that is about GPU rendering in Arnold, and I will see you in the next lesson.